Lights.
Do a little right.
Here we go. Excuse me.
Go, go.
Yes, on the video. Thanks, Steve. All right. So I want to run through this, and then I want to focus on what today's assignment is, mainly the word problems that come on today's. Got it? So let's run through these real quick. So problem number 1 looks like this, which is this, which is this. Agree? And then if that goes onto a number line, we have 0 here, we have 4 here. It's an open dot going this way. That all right? And then number 2, we have 4x plus 3, that's a 4, is greater than or equal to 3x minus 2. Subtract 3x, subtract 3. So I got that. So I have negative 5 down here. I got 0 here. This is a solid dot here. Shading this way. Okay? All right. Then 3, 4, let's see. Number 3, or wait. You got negative 1 because you didn't recognize your sign. When I subtract 3, that becomes a negative 5. And then write interval notation, yeah. So then this one should have went from negative infinity to 4. And then this one should have been a square bracket from negative 5 to infinity. There's your interval notation. Thank you. Yeah.
On number 3, I know we haven't gotten there, but what is that like equation called?
Linear inequality.
Even with the
Because you have x and y, it means it's linear,
alright.
and they're not raised to any powers or
So
anything.
it's not called anything different.
Oh, it might be. I'm not aware of it. Anything off the top of my head. 4x minus y is greater than 2, so I have negative 2 comma negative 2. Okay, and negative 8x minus y is less than 4. 0, 2. Okay, so we did show yesterday to graph, but before we graphed, we showed that these can go along with finding a point and determining if that's part of the solution. So this will either give me a true or false. So that's an x or y. So I'm going to get 5 times negative 1 plus 7 times 2. We want to know if that's less than 10. So I get negative 5 plus 14. Is that less than 10? Is 9 less than 10? That's true. So yes, this is a solution. That's one of the solutions. There's infinite amount of points that are the solution. And that happens to be one of them. Okay, again, this is an x and a y value. Let's plug them in. So I get 4 times negative 2 minus negative 2 is greater than 2. So that's negative 8 plus 2 is greater than 2. So negative 6 is greater than 2. Is negative 6 greater than 2? So that's false. So that is not one of the solutions. It's on the side that you wouldn't have shaded. Okay, again, this is an x and a y value. So I have negative 3 times 3 minus 2 times negative 3. We want to know if that's greater than 0. So that's negative 9 plus 6. Is that greater than 0? Is negative 3 greater than or equal to 0?
Yes.
No. So this is not a solution. Okay? And then this one, last one, x and y, let's plug those values in. So I get negative 8 times 0 minus 2, is that less than 4? 0 minus 2, is that less than 4? So is negative 2 less than 4? Yes. So yes, this is a solution. Cool? All right, so it looks like we have this graphed, and then we want to answer 7, 8, and 9's questions. Okay, so let me just pull this up. Graph, Cartesian. Across that. Negative 6 across that. then positive 3 crosses that right here. And that's dotted. And then, is this shaded over here? So let's change pens. So it's shaded over here, right? Is that correct? Is that what it's doing? No, I'm not going to shade the whole thing in for you. So they tell us that this is this graph. Okay, so explain using the graph / inequality why the point 3, -2 is not a solution. Okay, so I could plug this in, and if I plug this in, it might tell me true or false. Or we could say, okay, where is 3 and -2? So 3 and -2 on this graph is right here. Is that in the shaded region?
No.
No, if it's not in the shaded region, it is not part of the solution. Okay? And then what about the point 3, 2? Is this in the... So this is not. Okay? And then which points are in the solution? So let's just do this in green. So 0, 5. Is that part of the solution?
Yeah.
Yep, it's in the shaded region. -3, -4. Is that in the shaded region? Yep. And then 5. What is that? 5, -2?
No.
Nope. Answer those. And 10, 11, 12. I saw a couple of you had this error. Okay, so let's put this up. Math, graph, Cartesian. And then problem number 10. We want x is greater than or equal to 4. Guys and girls, I can't tell you how many times I keep seeing this. And it's the same people making the same mistake. So look up here, pay attention to what I'm doing. Let's figure it out. So this is the point x equals 4. Am I done?
No.
What do you mean I'm not done? I have a point.
You have to graph it.
I have to graph it. What kind of graph is it?
It's a vertical.
It's a vertical line. Okay, so this is a vertical line that goes right through here. Is it solid or dotted?
Solid.
Solid. It's not a dot. It's a line. Okay, so now I want values that are bigger. So again, we talked about yesterday, an easy test point is 0, 0. But what's strange about using 0, 0 is I'm only looking at the x value in this case because the y value doesn't exist. Okay, so is 0 greater than or equal to 4? No, that's on that side of the graph, correct?
Correct.
So that means I'm going to shade over here. Correct?
Yes.
Done. It's not a dot. It's a dot back here when I have an x value only. Here, I have an x value, but we have a Cartesian plane. Oops, wrong one. I have a Cartesian plane, an xy axis. Okay, so it has to be a line. And if it's x equals a number, it's a vertical line. If it's y equals a number, it's a horizontal line. It doesn't change from the day of the week. X is vertical, y is horizontal. X has an undefined slope, y has a slope of 0. Okay? So, with that known, let's go to the next slide. We have number 11. Oops, let's get out the highlighter. Number 11, y is less than -6. It's a line. What kind of line? Straight. Good. I'm not talking about any curved lines in here.
Horizontal.
It's a horizontal line. So this dot is way down here, right? Is it solid or dotted? Okay, so here. Okay, is 0, 0 a pretty good test point?
Yeah.
Yeah? What's strange about using 0, 0? Well, in this case, I'm only going to use which part of it?
Y.
The y component. Yes, x and y are the exact same thing. I get it. But I'm only using this part. Is 0 less than -6?
No.
No. So I'm going to shade down here. I'm going to shade on the other side of the graph. Okay, sorry my graph didn't show enough. I could have changed the size of it. Okay, Number 12. We have, what is that? Is that x is less than 0?
Yeah.
Okay. It's a straight line. What kind of straight line? It's a vertical one. Okay, so x equals 0 is indeed right here. So this is a vertical line. Solid or dotted? Dotted. Can I use 0, 0?
No,
Why not?
because it's on the line.
It's on the line. So I have to pick a different test point.
1, 1.
So 1, 1? Okay. 1, 1 seems okay. That's definitely on the right side of the line, agree?
Mhm.
Could I pick like, 5, 0? Yeah. Could I pick way down here? Yeah. Could I pick something over here? Uh-huh. But 1, 1 is definitely on the right side of this line. So I'm going to use 1, 1. I'm only going to use the x value. Is 1 less than 0?
No.
No. So this side, everything is false. So this side, everything is true. Done. Yeah.
Is that ever possible to do a cross multiply?
No. Well, let me take it back. When we have two linear equations drawn on the same graph that crisscross each other, there will be one of the regions that gives you false, false. Okay? Yeah. Let me finish this and then we can go. Is that cool? All right. Yeah, we'll get on to that. Number 13. Okay, math, graph, bless you. Cartesian. Y is less than 3x plus 2. I know it's a dotted line. Agree? It has a y-intercept of 2. Has a slope of what? 3 over 1. So from here I'm going to go up 1, 2, 3 over 1. And I'm going to do a dotted line. Does 0, 0 work as a test point?
Yes.
Yeah, it's definitely on this portion of the graph. Okay? So 0, 0 works pretty good. So let's see if it works. Let's plug it in. Excuse me. 0 is less than 3 times 0 plus 2.
Yes.
Yeah, what?
The slope is 2x.
Oh, it is? I wrote it down wrong? 2x plus, oh, that's a 2x, okay. So let's just change color. We'll make this purple. So this up to right 1, it's going to be pretty close. Ignore the blue, it's now the purple. 0, 0 still work?
Yes.
Okay, so let's plug that in. So that's 2 times 0. So is 0 less than 0 plus 2 is 0 less than 2?
Yes. Yes.
Oh, yes.
Yeah, that's true. So this gives me true over here. There's our shaded region.
So if you don't do like the graph for like length or whatever, could you just
Okay. 14. Okay. I guess we could try the cover method on this. It's going to be tougher on the cover method because it doesn't come out to whole numbers, but we can still try it. So we use the cover method. I have 0, comma blank, and blank, comma 0. So this cover up the x, so y is negative 2. So 0, negative 2, that works right here. And then if I cover up the y component, I get negative 3x equals negative 2. So it's going to be positive, and that would be 2/3. Is that right? Did I do that right? Yeah.
Could you do like add 3x?
Uh-huh. I sure could have. And it would have been the exact same answer. Yeah. So I just chose to do this because it just worked for me. All right. So 2/3 is not impossible to graph. 2/3 is roughly right there. Is this a solid or a dotted line? Solid. Okay. Hey, does 0, 0 still work?
Yes.
Yeah, it's close to the line. Do you agree? It's close to the line. Thanks, bud. Cool. Yeah. All right. Thank you. That's it. Kenny. All right. So 0, 0 does work. It's close to the line, but it still works. All right. So let's try 0, comma 0. See what works. I get negative 3 times 0 plus 0 is less than or equal to negative 2. So 0 is less than or equal to negative 2. False? So where do I shade?
Opposite side.
Over here. Over here in this region, over here, right? Cool? 14, 15. Wrong graph. Undo. Alright, number 15, we got x minus 2y is greater than or equal to 6. Looks like the cover method is going to work. It's set up in a standard form. So 0, comma, blank, and blank, comma, 0. So if I have 0 for the x, I cover that up. Negative 2y equals 6. So y equals?
3.
Negative 3. Correct?
Dang it. I got the whole thing wrong.
Alright. And then, let's see, I'm going to cover up the y, so x equals 6. Solid or dotted? Solid. Does 0, 0 still work for us on a test point?
Yeah.
Sure does. Okay, that's definitely on the top side of the graph. If it happens on the bottom, do something else. So I have 0 minus 2 times 0 greater than or equal to 6 is 0 minus 0 greater than or equal to 6. Is 0 greater than or equal to 6?
No.
That's false. So I'm going to shade the side of the line that doesn't have 0, 0. So I'm going to shade down here. Cool? Almost done. Okay. Number 16. They gave us this. Let's see. Math, graph, Cartesian. So that looks like here and here, and then it's dotted. So let's slowly go through this problem and answer, and then we don't have a shaded region, do we? No, so it's not going to be an inequality. But let's just, for sake of argument, let's say that this region is the region that's shaded. Is that okay? So let's say that's the shaded region. So that way we can make it an inequality, being the shaded part didn't show up. Okay? So, is this, which set of signs do we start thinking about? Top or the bottom? Why the top? Because it's dotted. So it's going to be one of these. Are you still with me? Do I know which one yet? Not yet. So it looks like I know the y-intercept, and I could probably figure out the slope. So if I used y equals mx plus b, what is my b value?
Negative 2 minus 2.
Negative 2. Agree? That's b. And if I wanted to find the slope, it looks like I can go up 1, 2, and over 1, 2, 3, 4. So the slope appears to be 2 over 4, which is the same as
1/2.
1/2. And then y. Now we have to figure out which sign is it going to be? Which one will work?
Use a point 0, 0.
So we're going to use 0.00. So we chose this top part to be the shaded region. Well, I did. So if that tells me, if I plug that in and it's true, so let's pick one of them. Let's go this. Okay? I'm just going to try one. So I'm going to try that 0, 0 in this equation. So I get 0 is less than 1/2 times 0 minus 2. Is 0 less than 0 minus 2? Is 0 less than negative 2?
No. Yes.
No. Is it?
No, it's not.
So what are you going to tell me the sign should be then?
The opposite way.
It needs to be the opposite way. Done. That's it. Hey, Jamel. Yeah, I just sent him. This is the second one. Yeah, he's just got one. Not. Here's Mel.
What? I'm bad? How much is there?
You want to miss the win?
No.
Just do it, Gentry.
Gentry. Gentry, just do it. Just do it. Just do it.
When's the last time you shared in these? No.
All right, sorry about that. All right, last problem. Talk to me. Shh. Oh, okay, then it would have been that way. Okay. All right, last question. Let's make this work. Math, graph, Cartesian. Looks like, does that cross at about 1, maybe?
Yeah, 1.
And then maybe back to -2, maybe? Is that about right?
Yeah.
And it's a solid line. All right. Shade the what?
Bottom.
Raise your hand if you want the top. 1, 2, 3, 4. Okay, that'll be the bottom then. All right. So we're picking the bottom to shade by vote, even though it wasn't written on the paper. Okay. So let's see. Let's decide which set of signs we're going to go with. The bottom one. Why? It's a solid line, so it has to be equal. So that's what we're going to choose so far. And being I could see, I probably figured out the slope. I can figure out the y-intercept. I'm going to use y equals mx plus b. What is my b value?
1.
Positive 1. Good. All right. So let's figure out what the slope's going to be. So if I go from here to here, how far did I go up? How far did I go over?
Up 1 over 2.
There you go. So what's my slope?
1 over 2.
1 over 2x. Okay? So let's pick one of the signs to plug in. So let's pick this one. Oh, that's an x plus 1. Is that all right? Is 0, 0 still an okay test point? Yeah, it's definitely down there. So let's see if 0, 0 works. Okay? So let's plug it in. 0 is less than or equal to 1/2 times 0 plus 1. 0 is less than or equal to 1. True or false? True. So with how we have it shaded, that's the appropriate equation. If you shade at the top, make that sign go the opposite way. Cool? Feel all right about this? All right, make sure your name is on that and pass it on forward. Double check, make sure your name's on it. And then what I would like you to do, I would like you to get out page 97, 98, which will be your homework tonight, but I want us to focus on page 98. Please. '97, '98, I think it is, or and, any more homeworks? You okay?
Quit coughing.
I'm coughing.
All right. Let's take a look at page 98. Let's take a look at page 98. Let's do this back page together. Is that okay? So problems 15 and 16, we use the same exact problem. So this is page 98. This will be the second page of your homework, but we'll do the second page together as a class. It says the school club ordered large pizzas at $12 each and regular pizzas at $9 each. I like pizza.
I like pizza too.
Problem when you start talking pizza word problems, you know where my mind goes to? Eating pizza. But that is what it is. Okay, so let's put down what we know. We know that the large cost the school $12 each, and the regulars cost $9 each, right?
Yep.
The club can spend no more than $180. Okay? So they have $180 that they're allowed to spend on these pizzas. Obviously, they're going to try and make some money selling these pizzas for more than what they purchased it for. Does that make sense? So the club can spend no more than $180 on the order. The equation modeling the situation is 12x plus 9y is less than 180. Oh, I guess we could make that equal to. I don't know if it's pivotal part of the problem. It might not be. It might be though. But they can spend. But they said no more than 100. Yeah, I think we're okay. I think it'd be okay with the equal sign. I think either way on this situation. All right. Ron, question? No. All right. So they said this models the situation. So X represents what? The large pizza, the number of large pizzas, and Y represents what? The regular pizzas, the number of regular pizzas. Okay? All right. Calculate and interpret. Okay. Ooh, we can do this. Okay. Let's go with. Alright, so let's go over here. We're going to math, graph. We'll go with Cartesian. Let's make this a little bit larger though. Oops, wrong button. And I think we can go with, let's not have any lines there. Let's erase that green. All right. You have a calculator out by chance?
I do.
I think we can use the cover method. So that means I'm going to go 0, comma blank, and blank, comma 0. So if I cover up the x, I get 9y equals 180. So if I go 180 divided by 9, I get what?
20.
20? And we'll scale that here momentarily. Let's go to the other one too. If I have a 0 on the y, so I get 12x equals 180. So 180 divided by x is how much? Or by 12 is 15? Okay. So I think what we can do is let's count these by 5s. So like 5, 10, 15, 20, 25, and then 30 over here. And then, well, I'm just trying to take a look at what this is going to do. Because I think by looking at the graph, it's going to help us. Okay, so 0, comma 20. So this point is here. And then this point is here. And let's just go with the original problem that it was a dot. It should be dotted. So I'm just kind of trying to think. These are some things that I would use as tools for this type of problem. Okay. Calculate and interpret both the X-intercept and the Y-intercept in the context of the problem. Yeah.
Why is the line dotted?
Well, the original line was less than. That's why. I mean, can we put make it solid in this context? Maybe. I don't know. All right, so. Yeah.
Does the line really make a difference, like if it's like this? I mean, normally it would, but like now.
I don't know. I don't know if it's going to be that much of a difference. So let's do this first. Calculate the X-intercept. What was the X value in our situation?
20.
What did X represent?
Large pizza.
Large pizzas. So they can buy 15 large pizzas and 0 medium pizzas, and that's what this means. What does the y-intercept mean in the context of this problem?
Yeah.
They can buy 0 large and what? 20 medium pizzas. Does that make sense?
We need to balance that out.
Okay, so calculate both the x and the y-intercept in the context of this problem. Well, they can either buy 15 large, and that gets them to the 180, or they can buy 20 medium, and that gets them to the maximum that they can spend. Okay? Now they want to know, is 10 comma 5, is 10 comma 5 a possible combination? Excuse me. Is that a possible combination? So I will tell you that this is the feasible region that we're going to focus on. Why am I not shading over in the negative regions?
Because you can't have negative.
Yeah, you can't call the Pizza Hut or the Domino's saying, hey, I want -5 large pizzas. They may say, what?
You can pay them.
Okay, so let's think about this. Let's take a look at how we have this represented. We want to know this point right here. This point right here. Now, did I draw a perfect situation? It might be close, and being that that is so close to that line, I don't know if it's going to work for us. So what I'm going to do is I'm going to take that 10 comma 5, and I'm going to plug it in. Okay, 10 comma 5. I'm going to plug it in and see if it works. So I get 12 times 10 plus 9 times 5. And you remember the original problem was this. So I'm going back to what the original problem said originally. That they gave it to us. So that's 120 plus 45 is less than 180. So that's 165 is less than 180. Is that true or false?
Yes, it is.
So could the club have ordered 10 large pizzas and 5 medium pizzas and still be under budget? Does that make sense? Now it doesn't tell us how much how much they're doing as far as sales go, but that club could do that. Well, that's why I'm going over this. All right, let's go to number 17. Let's go back to a full screen now. Oops, nope. I won't get out of there. Single. Number 17 says, okay, write the appropriate equation or inequality, so it might be an equal sign, for each situation described. Okay, number 17. Let X be the number of hours worked by Shannon and Y be the number of hours worked by Jesse. The sum of their hours worked is at least 50. What does at least 50 mean?
Equal to
X plus Y is greater than.
So at least 50. Got it?
Wait,
Or is it the other way?
it's the other way.
Say
Sure.
that way.
Let X be the number of hours. So let's do this. Shannon X plus Jesse Y be the number of hours worked by Jesse. The sum of their hours is at least 50. Do you think they worked more than 50 hours? At least 50. They worked at least 50 hours. So what's the smallest amount of hours they could have worked?
50.
50. Is my sign correct?
No.
I need to flip this over. It needs to be this sign. They have to have worked at least 50 hours. They could have worked 51. They could have worked 60, but they did at least 60 or 50 hours worth of work.
Wait. Oh, no. I thought you were saying it's supposed to.
Okay, so I guess technically, do I need this or this? No, I can do this to be my answer. I don't need to know that Sarah is X and Jesse is Y. They told us in the context of the problem. Okay, number 18. Number 18. Let X be the cost of a large pizza, so X is large. And let Y be the cost of a regular pizza. Still thinking, want some pizza. Sorry about that. Let X be the cost of a large pizza and Y be the cost of a regular pizza. 7 large and 5 regular pizzas were ordered at a total cost of $155. 7x plus 5y has a total of $155. Let X represent the cost of a large. Let Y represent the cost of a regular. So 7 times however many larges we buy plus 5 times as many regulars we buy will equal 155. We'll total that. So this one's an equality. I wasn't trying to be less than $155. I was trying to get to exactly that amount. Make sense? Number 19. Y is at most 9 less than twice the value of X. So if we're saying at most, do you think it's an equal? No. Okay, so 9 at most. We're going to use either this or we're going to use this. We don't know yet. We'll get there. We'll figure that out. So Y is at most 9 less than twice the value of X. 9 less than twice the value of X. So the reason I put an equal in there is said is. And then we have at most. So you can't have any more than Y. So Y has to be less than or equal to 2x minus 9. I have at most a certain amount. So I can't have any more than Y. And then number 20. So sometimes these word problems, you can tell that mathematicians were not grammar people because, sorry, in the world of grammar, if you were to write a book, it is at most X is greater than John's daily salary. What does that mean? This book sucks. So it's a good thing math teachers don't write books. Y is the cost of a plane ticket. X is the cost of one night in a hotel. Airplane. Hotel. The cost of a plane ticket is 80 more than 3 times the cost of. The cost of a plane ticket is 80 more than 3 times the cost of an airline ticket. The cost of an airline ticket. So the airline ticket is 80 more than 3 times the hotel. Airline ticket is going to cost more. So it's 80 more than 3 times the hotel. So if the hotel costs 100, this is 300. So the airline ticket would be $380. If the hotel was, $20, then this would be a $140 airplane ticket. Okay?
Wait, this is true.
Yeah.
I got y plus 80 is bigger than
Nope.
x.
The airline ticket costs more. The airline ticket is the cost of the hotel, triple the cost of the hotel with 80 added to it. Okay? So your assignment, obviously we got page 98 done. Your assignment is going to be page 97. So tomorrow we are going to do in class a Schoology review. And then Thursday we have a regular review. And then Friday we have our test. Okay? So we have quite a bit of review time in there. Sound good? Sweet. Good lessons today, everybody.